Gotcha.
You guys aren't writing inappropriate things on there, are you?
No, I messed up. That's all.
I think that'd be funny. Physics is fun because Murray sucks.
Mark Winner. Back to your home. Here we go.
This little private school. I taught with a fellow that went to the same college I went to. My father was a professor at this college, right? And thank you. He was a professor at this college, and this guy was a major, an English major. My father was a Shakespeare professor, so I knew this guy had taken my father as a professor. He had to, right? And so I asked the guy, I go, oh, do you went to Macalester? Yeah, I went to Macalester. You know, what year did you graduate? Blah, blah, blah. Did you ever have Professor Murray? And the guy before he thought you a bunch about him says, yeah, he was a worthless son of a, right? And then he turns bright red because he immediately realizes, I'm his son. Which is was the typical experience with my father, was that people either absolutely loved him or really hated him.
Why would they do that?
Why could they hate him? I don't know. He's pretty intense and opinionated.
So?
And I don't know, you would think. That would be, I know it's the back.
This, got it.
Yeah, I'm a six-rate champion at this.
I think I was twisting it wrong.
La. Oh. La. All right. Now, here's what I know. Here's what I know. I know that the velocity, I'm sorry, the mass of that cannon, okay, is 7.5 kilograms plus or minus a half a kilogram. And I know this because I actually stuck that thing on one of those little triple beam balances I have here, right? And I used like an unacceptable number. There's like attachment weights you can put on the side to make it like read what it says on there, plus a kilogram, plus 2 kilograms. I actually stuck 7 of those on there. Okay, I don't think this is like what the manufacturer would want me to say. So I'm going to say it's 7.5 plus or minus a half a kilogram. Because, you know, it's pretty hard to mass something that heavy, right? Okay, these tennis balls have a mass of, oh, you know, I would say like a tennis ball like this. You're talking about a tennis ball like this, right? I would say that it's got a mass of, and I'm just going out on a limb here. It's got a mass of about, I would say, I'm just guessing, that it's about 66.5 grams. Yeah?
Something like that.
Yeah, just about, you know. And this other one, the second one is, oh, it's less. 66.5. $61.8. What were they? 66.5, 61.8? 66.5, 61.8. What was it, 61.8? Okay, so there's 2 trials. So on your paper, you're going to have to do 2 different calculations. One's with 1 tennis ball. And then I guess this one, it's this is trial 2. I better do it this way, left to right. 66 point, what was it, 5? This is trial 2. Right, so let's do the first calculation here. And that is that on trial 1, it went 3.28 meters. Yeah? Okay? So the velocity is, the initial velocity is 3.28 times 2 divided by, what's our time? Well, our times were, for trial 1, 7.58, 8.65, 8.55, right? This distance here was 3.03 divided by, we're going to have to figure out the average time, right? And the times were 9.69, 9.80, 9.50, like that, okay? Okay, so I think the thing to do here is take the average of these. And all right, so get a calculator out. You're going to need to calculate something. $8.26. So go ahead, once you've averaged those guys, go ahead and figure out what the initial velocity was. Is it conceivable that right after the explosion it was going about 80 centimeters a second? It could have been going that fast, right? That seems reasonable, doesn't it?
What's the 3.28?
3.28 is how far, when I'm using this formula here, so it's 2 times the distance over the time. So it went 3.28 meters before it stopped, and it took 8.26 seconds. That's the average time, right? Okay, are we ready for the momentum calculation? Are we ready? Yeah, we are. Okay, I'm going to make this guy go to the left and make the tennis ball be a positive momentum, right? So I'm going to say 7.5 times negative 0.7942 plus, and then the tennis ball is 0.0618. Right, because you got to divide by 1,000, 1, 2, 3, right? Times V equals 0, right? Momentum after the explosion equals a momentum before, and we know that was 0. Can't we do that? It's simpler to just say that the two, mv equals mv, but I like never to let go of the negative sign and the vectorness of the vector, because we have to maintain our discipline. So go ahead and solve this for v. That'll be the velocity the tennis ball was going. Don't call me that in public. That's what Kaylin's math teacher says when people say that. That's even better than, like, what do I say? You guys get 96 meters per second. Is that fast?
Yes, it is very fast.
That's pretty fast. It's not as fast as we've booked. I think this stuff had sat around and got exposed to the air and got moisture. It's 215.6 miles per hour though. Right? I just said times 2.237. This is not, by any means, you don't have to do this. I'm just doing it for fun. That's 215.6. I think it would qualify for the Indianapolis, right? Oop, miles per hour. Right? God, we had a really hot one this year. It was like 300 miles an hour or something like that. Duggan, the story, did I tell you the story about Duggan and the little school spirit bear? This guy, like, the head of which is up there. Did I tell that story? Duggan sticks one of those in front of it, which on the face of it might seem like it's counter to school spirit, right? But, let me preface this with just saying that he expected it fully to just get hit by the tennis ball and sent flying, because they're so light, right? A tennis ball wouldn't rip one apart, would it? No, right? No. the tennis ball hits that thing, right? They have little beanbag